Hi everyone. So on the previous slide, you saw some of the differences between linear and quadratic equations. What we're going to practice doing is graphing quadratic equations. And we know something's a quadratic equation when the highest exponent and term is x to the squared. That means that it's a quadratic. Okay? And then quadratic equations, when we graph them, you don't necessarily have to write this down, but when we graph them, they're going to come out as parabolas. So they're either going to be facing up like this, or they're going to be going down like this. And we can move these parabolas wherever we want. Like we can have them going here. It all depends on our equation. Okay, but just a little rough idea for how these are going to look. They're going to be curves. Let's go ahead and delete this. Okay, so the easiest way to graph quadratic equations is to actually take that equation and to just identify each of the intercepts. So I want to first identify the y-intercept, and then we're going to go ahead and do the x-intercept afterwards, but let's focus on the y for now. So remember, in any type of equation, any type whatsoever, if you want to find the y-intercept, that means you have to set x equal to 0. Because remember, if we're talking about my y-intercept, that means it's where my graph is going to intercept the y-axis. No matter what point this is, my x will always be 0. Okay, so that's why we set x equal to 0. Just giving you a little background info. Okay, so what we're going to do is we're going to go ahead and rewrite this equation, but instead of x, we're going to plug in a 0. So I have y equals -5, but instead of x squared, we're going to go ahead and do 0 squared. So 0, then to the second power. We know that 0 to the second power is just 0 times 0, which is just 0. Okay, so we plugged in 0 for x. Next, we would do this exponent, which is 0 to the second power, which is just 0. Then it's -5 times 0, which is just 0 again. So it's just a bunch of zeros. But then we have to bring down that plus 20. Now our y is going to be equal to 0 plus 20, so our y is 20. So that means that our y-intercept, or where this parabola is going to intercept the y-axis, is going to be up 20. So the entire point is over 0 up 20. And I'm just going to box these off so I can come back for them later. This is my y-intercept. Next, I'm going to go ahead and get my x-intercept. Let me rewrite the equation. 5x squared plus 20. To get the x-intercept, you're going to go ahead and set y equal to 0. And I know this particular problem isn't on your slide, but I do suggest doing all of this work with me, because you're going to do some stuff on your own in a second. Okay, so to get your x-intercept, you do want to set y equal to 0. So I'm going to now take this equation, and instead of y equals, I'm going to put 0 equals. And then just rewrite everything else. -5x squared plus 20. So this is where my y used to be. So from this point, what I want to start doing is I want to start isolating this x variable, or I want to start getting x alone. In order to do that, remember, we have to get rid of everything else that's on the right side of this equal sign with it, starting from the furthest thing away. So it's like starting from the outside and working your way in. So we got to get rid of that positive 20 by subtracting 20. So I'm going to go ahead and subtract 20 on both sides. And then on this other side of the equation, so I'm going to subtract 0 minus 20. Over here, these two will cancel. I can just bring down my -5x squared and my equal sign. And then I actually do this. 0 minus 20 is -20. Make sure you know that it is a -20. That's very important. Okay. Then from there, to get your x alone, we have to get rid of that -5 in the front. We can do that by dividing by -5 on both sides. These two will cancel, and I can just bring down my x squared, or my x to the second power. Now I have -20 divided by -5. which is 4, and a negative divided by a negative is a positive, so it is positive 4. Remember, you don't have to necessarily write that little plus sign, but I just put it there. Next, the x is almost alone, but we have to get rid of that x squared. So remember, we get rid of squares by doing the square root. So I'm going to take the square root of both sides. The square root of x squared is just going to be x. The square root of 4, remember it's plus or minus 2. Remember we practiced this little plus or minus last time. Technically there's one here. The only reason is because negative 2 times negative 2 equals positive 4, and positive 2 times positive 2 equals positive 4. So technically the square root of 4 is positive 2 and negative 2. So then I can split this up and say x equals positive 2, x equals negative 2. So then I'm going to go back up and say, okay, what was the whole point of this again? It was to find my x-intercepts. Oh yeah, so now I have two x equals. So if I think about my graph, that means that these two, x is positive 2 and x is negative 2, that's where the x-intercepts are going to be of my graph. These points would be 2, 0 and negative 2, 0. Negative 2, oops, positive 2, 0. And negative 2, 0. So let's actually put all of these points on an official graph now. I was doing a little sketch off to the side. But I'm going to just do a quick graph. It's not going to be perfect, so bear with me. Ooh, this is really ugly. 1. And then, okay, so I did my x-axis. Please ignore how ugly this is. And my y-axis. So my x-intercepts were positive 2 and negative 2. So I'm going to go ahead and plot those points there. So positive 2 and negative 2. And those were 2, 0, negative 2, 0. My y-intercept, if we go back up to my y-intercept was y equals 20. So that means I have to go up to 20 here. I'm going to count by 5s. 5, 10, 15, this would be 20 here. Over 0, up 20. Okay, so I have my two x-intercepts. That's what I got from here. I have my y-intercept that we got when we set x equal to 0 way up top. Now the whole thing is, well, what did we do all this for? We did this to graph the quadratic, remember? We wanted to graph this situation, and that's when we found the y-intercept, we found the x-intercepts. I know that since this is a quadratic, it must look like a parabola when I graph it. So that means this graph is going to loop together like a U, like this. And I'm actually going to extend it down because this graph technically goes on forever here, with these just being the intercepts. So what we're going to look at next is a sample problem that I want you guys to try a little bit on your own. This problem is on the slide on the right-hand side. It says, imagine you are standing on the roof of a 12-story building and you throw a water balloon down the sidewalk. The function, f of x is equal to negative 3x squared plus 12, represents the path of the water balloon. Find the x and y intercepts of the function, and then it just restates the function. So I know word problems can be intimidating, but if we highlight what they're asking us to do, find the x and y intercepts of the function. I know how to do that. We know how to do that. So don't be intimidated by the word problem aspect of it. We'll actually come back and talk about how the word problem relates to the work we're going to do in a second. Let's go ahead and just do what it wants us to do and find the x and y intercepts of this function. First things first, when I take the function, I like to switch out this f of x with y. So instead of f of x equals, I'm going to put y equals, and then negative 3x squared plus 12. That just helps me out a little bit more for identifying my intercepts. And then we're going to go ahead and find the y-intercept. So remember, to do that, we have to replace x with 0. And then we're going to go ahead and find the x-intercept. And in order to do that, you have to replace y with 0 and do some solving. Go ahead and try those on your own. So what I want you to do is I want you to press pause on this video and then try this problem and see if you're able to get the y-intercept, both x-intercepts, just one, and see basically where to go from there. So go ahead and pause the video and then don't press play until you're ready to go over it together. Okay, if you are ready to go over the video, we're going to go over it, the problem. We're going to go over it. If you do want more time to work on your own, please press pause. Okay, so to find the y-intercept, I want to go ahead and set x equal to 0 here. So I'm going to take this equation and I'm just replacing x with 0. So instead of x squared, I'm going to put 0 squared. I know that this entire thing turns to 0 because anything multiplied by 0 is just going to be 0. So then I'm left with y equals 0 from this mess. And then I bring down that plus 12. So y equals 0 plus 12 is just 12. And remember, this is my y-intercept. So the entire point on my y-axis would be over 0 up 12. Now to get my x-intercepts. So the x-intercepts, we have to replace y with 0. So instead of y equals, we're going to have 0 equals, and then the rest of the function, negative 3x squared plus 12. So once you're at this step, how it's different from the y-intercept side is the y-intercept side, we have our y equals, and then we're able to just simplify the right side of the equation. On the x-intercepts, we can't simplify this right side of the equation here because I can't combine these terms because they're not like terms. So instead, what we're going to do is I have to start isolating the variable, the x squared, or the x actually. So I'm going to do that by first subtracting this positive 12 on, subtracting 12 on both sides because it's the opposite of that positive 12. Then these cancel out, positive 12, negative 12 cancel. I can just bring down this negative 3x squared, bring down the equals, 0 minus 12 is negative 12. Next, to isolate the variable, I'm going to go ahead and divide by the coefficient, so I have to divide by negative 3 on both sides. Negative 12 divided by negative 3 is positive 4. These will cancel, and we're left with x squared. Now remember, that's not the end, that's not where we stop. We have to, from here, take the square root of both sides. And remember, there's always that little invisible plus or minus in front of the square root. So the square root of 4 and the square root of x squared. The square root of x squared is just x. That's why we do this step, is because we want to get just x by itself. The square root of 4 is going to be 2 plus or minus 2. So that means technically x equals positive 2 and x equals negative 2, which are the same x-intercepts from our original problem, but that's just a coincidence, where these entire points would be 2, 0, and negative 2, 0. Okay, and then let's go back up to the problem. The problem wanted us to find the x and y-intercepts of the function. We did that right here, our y-intercept and our two x-intercepts. Couple things I want to mention is, in terms of the word problem, where does all of this information fit in? So let's see. Imagine you're standing on the roof of a 12-story building. Okay, so I'm going to draw a little building. Roof. Okay. And you throw a water balloon down to the sidewalk. So this is me. I know this is weird. This is my water balloon. And I'm throwing it down to the sidewalk to where eventually it's going to splat. The function, then it gave us that function, represents the path of the water balloon. So what that function represents, it represents this dotted line I created. And as you could see, that's pretty much half of a parabola. So if we think about what all of our intercepts mean, so I know the problem didn't necessarily ask you to do this, but I just want to make sense of it. We have our y-intercept is 12 over 0 up 12. So that would be, let's say here, over 0 up 12. We have my two x-intercepts, which are 2, 0, and negative 2, 0. So what this represents is that this is the path of the water balloon. But notice the water balloon, it's only going to travel, this is like the 12-story building here, and this is how it splat on the sidewalk here. We have this x-intercept also, so technically this function by itself goes down like this to where it looks similar to like our last problem. But in terms of the word problem here, we know we got very messy, but in terms of the word problem, the only x-intercept that makes sense is the positive x-intercept, because the water balloon's only going to go in one direction. It's not going to go like forward and backward. So if you imagine me here, I threw this water balloon, bam, splat. It's not going to go backwards also. So for word problems, we can actually disregard this negative x-intercept. And we could say something like it's irrelevant for the word problem. Because our word problem isn't, we're not going to go negative. We can't throw our balloon negatively. So technically for this word problem, your y-intercept is 0, 12, which you could think of that as your 12-story building. And your x-intercept is 2, 0, which is where it hit the sidewalk. So if you think about it, your building's here, boop, and this is the sidewalk there.